Any question from previous session? Aarti, Ashwini, Rupa, Vivek. We are trying to focus on security policy concept, security policy and NAT policy. How to configure security policy and NAT policy in Palo Alto Firewall device. Ravneet, can you hear me?
Hi everyone, good evening.
Any question, everyone, from previous session? Aarti, Ashwini, Rupa, Vivek, Ravneet, from previous session. Can we continue our topic now? Can we start?
Yes, Jizu, please go ahead.
Okay. So it's the same topology, okay? It's the same design. Our topic is security policy and NAT policy. So as per our policy configuration, this inside machine, IP address we are using here, IP config 200.200.24. So from this LAN machine, I'm trying to initiate my traffic for outside machine. Outside IP address is 99.99.99.10-T, and traffic is not traveling through the firewall device. Remember our policy configuration, everyone, and policy sequence, policy order.
Yeah, since we moved up the rule number 2 above, that's the reason we are not getting the reply. But yeah, if we move the rule number 1 up, then we'll start getting the ping.
Yes, as per this policy configuration, as per this rule number 2. Okay, when this inside machine trying to initiate its traffic, this traffic will go and hit on firewall device. Firewall will check this traffic information into firewall policy, into security policy. Okay, it will always check from top to bottom. Okay, firewall will check any traffic information in firewall policy always from top to bottom. As per this top rule, rule number 2, this is a rule name. Okay, rule 2 is a name. As per this top rule, if marketing team 1 from LAN side network trying to access any destination on WAN side network, action we are using deny. Okay, so traffic is not traveling as per our task. Traffic is not traveling through the firewall device. You can verify IP address configuration here. IP config. So 200.200.24. 24 is a part of 20 to 50 IP address. Let's change IP address here. Let's change IP address here. So IP address I'm using, for example, 100. You can click on OK. You can click on OK. This time I'm trying to initiate my traffic for 99.99.99.10, and you can see traffic is traveling. Can anyone help me? Traffic is traveling now. Can anyone help me?
Yeah, since we have only restricted the IP range from 20 to 50, so it will only go ahead and restrict and deny the traffic from IP range 20 to 50. If it falls outside, then it will come in the category any as per rule 1, and it will flow.
Yes, this IP address we are using .100, right?
Mhm.
.100 is not part of this marketing team 1. So far, this traffic is not matching here into this rule number 2, into the stop rule. Then firewall will check this traffic information in next rule. And in next rule, we are using source address any. So this 200.200.24 is a part of any. So as per this second rule, traffic is traveling through the firewall device because action we are using allow. So I hope security policy concept is clear, how to create, how to work with security policy, everyone. I hope this point is clear. Perfect. Now, so in case, see, in case if traffic is traveling from LAN network, traffic is traveling from private network to public network in a real network. I'm talking about real network. Okay? In a real network, if traffic is traveling from private network to public network, then you need translation. You need translation. Without translation, private IP cannot communicate with public IP. We need to translate our private IP into public IP. And for translation, we can go with NAT concept. Okay, NAT concept. It's a L3 feature, NAT concept. So the topic is now NAT, network address translation. Whenever traffic is traveling from private network to public network, we need to go with translation method. And for translation, the concept is NAT. What is NAT? NAT we are using to translate one IP into another IP. It doesn't matter. Okay, you want to translate private IP into public IP, or public IP into private IP, or private IP into private IP, public IP into public IP. It doesn't matter. Okay, NAT we are using only for translation. Only for translation. For example, we have a simple design. Wait. For example, I have one firewall device. Okay, this is L3 appliance, firewall device or router, you can say. Okay, netted device, you can say. So I have this router device. This router is connected with LAN side portion. This is your private network. In your private network, you have multiple computers this side. And IP address we are using 192.168, 10.10, 10.11, 10.12, 10.13. This side we are using as a ISP side portion, public side network. So this portion, my point is, this portion of the network we are using as a private network, LAN network. In private network, we are using private IP. And this side we are using as a public side network, ISP side network, internet side network. So now in case if this inside machine, this 192.168.10.10, if this inside machine private IP trying to go to outside to access any public resources, okay, trying to access internet traffic, then you need to translate this private IP. You need to translate this private IP into public IP. You need to translate this private IP into public IP. And for translation, we have a method. It's called NAT, network address translation. It's a method. In NAT, we have translation configuration option. In NAT, we have translation configuration option. We can go with static NAT configuration, or we can go with dynamic NAT. We have one more option, and a very popular option. It's called PAT, port address translation. Port address translation. So we have translation configuration option, static NAT, dynamic NAT, and PAT. So let's talk about static NAT first. In static NAT translation method, in translation option, you need to create all translation entries statically, manually, you can say. For example, in LAN side portion, I have 10 computers, 10 private IPs. So I need 10 public IP. Now, for example, 99.99.99.1.2.3.4 and so on .10. So for 10 private IP address, I need 10 public IP. With a static NAT configuration, so you can say static NAT, you can say one-to-one translation method. In static NAT, you can create all your translation entries statically, manually. And it's a one-to-one mapping. You can map one private IP with one public IP. It's a one-to-one mapping. So in a static NAT, I can map this 192.168. For example, this 192.168.10.10, this IP with 99.99.99. This private IP, I can map this private IP, I can map with this public IP 99.99.99.2. So whenever this 10.10, this 10.10 machine is trying to travel outside, it can get this public IP and traffic is traveling to outside. As per static net, one-to-one mapping. If 10.11 is trying to travel outside, it can get this public IP as per your static net configuration and traffic is traveling to outside. Clear my point, everyone? Aarti, Ashwani, Rajat, Ravneet, Rupa, Vivek.
Yeah.
So in a static net, we can create all translation entries statically, manually. Static net is bidirectional. Okay? Only static net. Static net is bidirectional. What does bidirectional means? As per static net configuration, okay, as per your mapping, this 10.10, this 10.10 is mapped with this 99.99.99. So whenever this 10.10 is trying to travel outside, it can get this public IP and traffic is traveling. Static net is bidirectional. It means if any traffic is coming from outside, for example, this outside user, when this outside user will hit on this public IP, So as per your static NAT configuration method, this public IP is mapped with this 192.168.10.10. So static NAT is bidirectional. If anyone from outside will hit on this public IP, as per static NAT configuration, your device will redirect this traffic on 192.168.10.10. So static NAT is what? It's a bidirectional. Static NAT we are using in a small network. For example, you have 5 computers, 10 computers. So no problem. You can buy 5 to 10 public IP. You can configure your translation method. But in case if you are working in a big network, for example, you have 100 computers, okay, in LAN side portion, you have 200 computers. So in case if you are looking for a static NAT configuration method, so for 200 private IP address, you need 200 public IP. In case if you are using static NAT configuration method, you need to create 200 entries statically or manually into this netted device. Statically or manually. It's a difficult task, okay? If I'm working in a big network, static NAT is a difficult task. I need to create 200 entries statically or manually. That's why in a big network, I'm not using static NAT. In a big network, I can go with dynamic NAT concept. Yes, for 200 private IP address, I need 200 public IP. Yes, I need 200 public IP. But this time, I'm not creating 200 entries statically or manually into this netted device. No. This time, I'm not creating 200 entries statically. In dynamic NAT, what I can do? In dynamic NAT, with the help of single command, I can create a range of public IP. With the help of single command, I can create a range of public IP address into this netted box, into this router device, into this firewall device. With the help of single command, I can create a range of public IP, pool of public IP. So this time, if anyone, for example, this 10.10 is trying to travel outside, it can get any IP address from this public range and traffic is traveling. If 10.11 is trying to travel outside, it can get any IP address from this range and traffic is traveling to outside. Okay, it's a dynamic NAT, but again, we have an issue in static and in dynamic NAT, we have an issue. For 200 private IP address, I need 200 public IP. This is the issue. For 200 private IP address, I need 200 public IP. That's why I'm not using static NAT and dynamic NAT. I can go with this popular option. It's called PAT, port address translation. I can go with PAT concept, port address translation. What is PAT? In PAT, we can translate multiple private IP address. With single public IP. For example, this is your public facing interface. And here you are using 99.99.99.100. So with PAT concept, you can translate multiple private IP address with single public IP. Okay, for example, if this 10.10, if this 10.10 is trying to travel outside, it can get this public IP and traffic is travel. If 10.11 is trying to travel outside, can get same public IP and traffic is traveling to outside. We can translate multiple private IP address with single public IP. Clear this point, Rajat, Ravneet, Rupa, Vivek?
Yep.
Aarti, Ashwani?
Yes.
Yes, Ashwani.
The point is clear, but I'm not sure like if the question is too early to ask, maybe you would be going ahead and getting that cleared near soon. But my question is like, since we have a range of private machines on the LAN side, if any particular user is doing any suspicious activity which is going ahead and going through this public IP port and going to internet, how will a firewall admin be able to go ahead and detect that which particular machine is going ahead and doing this malicious activity?
Which
So
particular machine and which particular user?
yeah,
We'll discuss, okay? We'll discuss this topic. It's called a user ID concept. We'll discuss this concept right now in our policy. We are trying to match only IP address, L3 and L4 information. We are trying to match. Ashwani, okay?
okay, yeah,
We can
that's what
add
I said,
user
that
account
this
information.
concept we'll discuss later.
Yes, let me tell you. See, right now in our policy, we are trying to match only source IP, destination IP, service or protocol. That's it. We are trying to match L3 information and L4 information. If you want to detect user information, so you can go with this topic, user ID. Okay. We'll discuss user ID concept.
Okay, sure. And one thing that I didn't understood about dynamic, you mentioned that we have a range of dynamic
In
and
dynamic NAT, you can create a range of public IP. You don't need to create 200 entry statically or manually. If I'm working in a big network, for example, I have 200 private IP address in LAN side portion. This side I have 200 private IP address. So if I want to allow everyone to access internet traffic, so for 200 machine, I need 200 public IP, right?
okay.
200 public IP. I need to buy 200 public IP. 200 public IP. My point is, if I'm going with static NAT, I can do this, but in static
Manually.
NAT, I need to create 200 entry statically or manually. Okay, I don't want to do that. Okay, I'm going with dynamic NAT concept. Okay, I don't want to create 200 entries statically manually. So I have another translation option, dynamic NAT. In dynamic NAT, I can, with the help of single command, I can create a range of public IP into this netted device.
Okay. And like this IP assignment, will that be done with the help of DHCP here, or
No,
how?
it's a NAT concept. No, it is not a IP address assignment. Okay, Ashwani, we are not assigning any IP address to machine. Okay, when traffic is traveling through the device, then we are trying to translate. We are trying to translate private IP into public IP. DSCP is what? In DSCP, you can provide IP address for communication, right? How to configure IP address in a device? How to configure IP address in a laptop and desktop? I can configure IP address statically. I can configure IP address with DSCP, right?
Yes.
It's a IP address configuration method. So all the devices, they have IP address. Now they are trying to travel to public site network. Public site. In public site, we need public IP. In private network, we need private IP. So this side, we have private IP address. These are what? Private IP address. When traffic is traveling from private network to public network, we need to translate. We need to translate private IP into public IP. We are not assigning IP address. Ashwani, clear my point?
Understood. But for a to and fro communication, what I'm trying to understand is, say, from the machine 10.11, the traffic is going out and it's hitting the port 99.1, and that's how it's reaching the server outside.
Yes, we are trying to translate We are trying to convert or change, you can say. We are trying to translate this private IP in public IP, because for public side communication, you need public IP. This
Public IP.
private machine cannot access internet traffic. In your modem, you have NAT
Yeah.
concept.
Mhm.
Without NAT, in any organization, without NAT, LAN side machine, they cannot go on internet side.
So, yeah, what I'm trying to understand is like for a to and fro regular communication, will it just continue to go through the same IP or it
No,
could
no,
be
it's
any
a,
random IP
no, I told you. If anyone trying to travel outside, they can get IP address from this public range.
through any range, right? It's
On this
not like
public
a
range. For
dedicated.
example, 10.11 is trying to travel outside, can get any IP address from this range.
Okay,
10.10 is trying to travel outside, can get any IP address from this range, and traffic is traveling.
sure. And in dynamic as well, is it also bidirectional?
I'm talking about dynamic. Okay, bidirectional. No, static NAT. Only static NAT is a bidirectional.
But dynamic is not.
No, only static NAT is bidirectional. Only static NAT.
Okay, sure.
Clear?
Okay, sure. Yeah, sorry for the disturbance. We
Clear
can
this.
continue with that. Yeah, thank you.
Any other question? Arti, Rajat, Ravi, Rupa, Vivek? Okay, wait. Now let's talk about PAT concept. So what is PAT? In PAT, we can translate. See, for 200 machine, I don't want to buy 200 public IP. No. So we can go with PAT option. PAT is a popular option. In PAT, we can translate multiple private IP address with single public IP. For example, if 10.10 is trying to travel outside it, this device will get this public IP and traffic is traveling to outside. If 10.11 is trying to travel outside, you can get same public IP. This machine is getting same public IP and traffic is traveling to outside. It's a PAT option. Clear this point? Clear this point, everyone?
Yes.
Okay, now what is packet format? What is packet format? Okay, this is not firewall concept anymore. Okay, it's a CCNA training. Okay, this NAT is what it's CCNA concept. We'll discuss how to configure NAT in Palo Alto Firewall device, but this is basic CCNA concept. So now let's talk about packet format here. What is packet format? What is packet format here? For example, these two devices, 10.10 and 10.11, these two devices, they are trying to access. Outside, we have a server, okay, 8.8.8.8. And both the devices, 10.10 and 10.11, both the devices, they are trying to communicate with same destination. They are trying to access same service. Same service. Okay, let's talk about packet format. So here we have source IP, source port number, destination IP, destination port number. Now, what is source IP into this task? 192.168.10.10. What is source port number? What will be the source port number? Can anyone help me? What will be the source port number? Any random port number. Remember? Everyone? TCP/IP protocol suite. If two devices they are trying to communicate with each other, device will assign source port number in between. It will assign a number in between 10242 to 65,535. So this machine will assign any source port number. Okay, for example, 52,000. Destination IP, this machine is trying to communicate with 8.8.8.8. And destination port number, this machine is trying to access port number 443. What is port number 443, everyone? HTTPS service, right? HTTPS service. So this inside machine 10.10 is trying to communicate with 8.8.8 for web services, for HTTPS service. Now this 10.11, wait. Now this 10.11 is trying to communicate with same destination. Here we have source IP, source port number, destination IP, and destination port number. So what is source IP? Source IP is 192.168.10.11. Source port number is a random port number, right? So I'm using, for example, 52,008. And destination IP is same 8.8.8.8. Destination port number is 443. My point is both the devices, they are trying to communicate with same destination. So when traffic will travel from this machine, this is actual traffic. Traffic will travel from here to this router. Now this router will create an entry first. This router will create an entry first for this traffic. And once it create an entry, then router will remove this source IP from this packet. Router will remove this source IP from this packet. It will put this outgoing interface IP as a source IP 99.99.99. And this traffic is traveling to outside. This is packet fault. Okay, this traffic is traveling to outside. Now, if 192.168.10.11 is trying to access same destination, traffic will go and hit on router device. Router will create an entry first. After that, router will remove this source IP information here. Router will put this outgoing interface IP as a source. So 99.99.99.100. This traffic is traveling to outside. Public IP is trying to communicate with public IP. Clear my point? Ashwini, Rajat, Aarti, Ravneet, Rupa, Vivek.
Yes.
Now, what about reply packet, everyone? What about reply packet? If 8.8.8, my point is, if 8.8.8 will send a reply packet, this reply packet will hit on router. My point is, when 8.8.8 will give a reply packet, how your router will identify this reply packet is for 10.10 or it is for 10.11. How your router will identify this reply packet is for 10.10 or it is for 10.11 based on port number. See, this traffic assigned 52,000 based on port number because router has entry. Based on port number, router can identify, yes, port number. See, because into this packet, you are only trying to translate source IP. Rest information is same. You are trying to translate only source IP into the scenario. You are translating your source IP only. The rest information will not change. So based on port number, your router can identify when reply packet will hit on this router device. Router can identify port number. Based on port number, router can identify, yes, this reply packet is for 10.10. Clear this point, everyone?
Yes.
It's a simple NAT concept, simple CCNA training. But now in firewall device, in any firewall box, in any firewall device, you can configure two type of NAT. In any firewall box, two type of NAT. The first one is what? Source NAT. And second option we have destination NAT, or in short, you can say DNAT. So in firewall box, we can configure source NAT and destination NAT. It's a common concept. in Palo Alto, in FortiGate, in Checkpoint, in FTD, in Cisco ASA, you can configure these two type of NAT, source NAT and destination NAT. Now, in this scenario, we can use source NAT concept. What is the scenario to use source NAT? So this one is a great example. This one is example for source NAT. This one is a source NAT, everyone. What you are doing into the scenario, you are trying to translate your source IP. And whenever you are trying to translate your source IP in any scenario, whenever you are trying to translate your source IP, it's called source NAT. It's called source NAT. So this is static NAT, dynamic NAT, and PAT. These are what? These are source NAT implementation options. So these are what? Source NAT. These are what? Source NAT. Static, dynamic, and PAT. These options are called source NAT. Static NAT, dynamic NAT, and PAT. PAT is called what? These are source NAT implementation. What is destination NAT? What is destination NAT scenario? In this scenario, we can go with destination NAT. Let's talk about scenario for destination NAT. Wait. Can we take a break for 7 minutes, everyone? Aarti, Ashwini, Rajat, Sabri, Rupa, Vivek.
Yeah, no worries, no worries.
Only
Sure.
7. Okay.
Sure.
We will continue at 6:40. Okay. Please turn off your mic.
Thank you.
Hi everyone, can you hear me? Aarti, Ashwini, Rajat, Ronit, Rupa, Vivek.
Yeah, hi Jitu. Hi.
Okay, let's continue our discussion now. Okay, so let's talk about DNAT, destination NAT. What is the scenario to use DNAT concept? Wait, I'm creating a design. Okay, so I have one firewall device, and this portion I'm using as a DMD side portion. Okay, here we have servers. These servers are publicly allowed for outside users. So these are servers. For example, this side we have company web server, IP address 192.168.10.10. This side we have company DNS server 192.168.10.11. SMTP server 192.168.10.12. And company FTP server IP address 192.168.10.13. Okay, this side I'm using as a ISP side network. This portion is what? ISP side portion. Okay, this is your public facing interface, fast Ethernet 0/0, and IP address I'm using 99.99.150. Now into this design, if I'm using PAT concept, remember our PAT discussion we want, port address translation. Into this design, if I'm using PAT, what is PAT? Port address translation. In PAT, we can translate multiple private IP address with single public IP. So this, if I'm using PAT here, so that if 10.10 is trying to travel outside, it can get this public IP and traffic is traveling to outside. If 10.11 is trying to travel outside, it can get same public IP and traffic is traveling to outside. So we can translate multiple private IP address with single public IP. So into this design, traffic is traveling from LAN to WAN. LAN to WAN. But now our task is different. Now our task is this time, our task into this task, traffic is not initiated from inside network. No, traffic is initiated from outside network. Traffic is coming from outside network. For example, if this outside machine will hit on this public IP. My point is, if this outside machine will hit on this public IP, then how your firewall will identify, okay, this traffic is for web server, or it is for DNS, or it is for SMTP, or it is for FTP. Clear this challenge, everyone? This time traffic is coming from outside. Traffic is initiated from outside. Okay, this is the issue. This is the challenge. So into this scenario, we have a solution. We can go with the static NAT. Remember static NAT discussion? Static NAT is what? Static NAT is one-to-one mapping, and it's a bi-directional. Static NAT is what? It's a bi-directional. So this side, I have 4 servers. So I can buy 4 public IP. For example, 99.99.99.151, 152, 153, 154. Okay, so I can map this public IP with this private IP. This public IP, I can map with this private IP, public IP, private IP, public IP, private IP. So in case if 10.10, if 10.10 is trying to travel outside, it can get this public IP and traffic is traveling to outside. Or if anyone from outside will hit on this public IP, as per static NAT configuration, your firewall will redirect this traffic on web server. So I can go with the static NAT into this design, no problem. But the issue is I have 4 servers, so I need to buy 4 public IP. In case if I have 20 servers, then I need to buy 20 public IP. This is the issue. 20, I need to buy 20 public IP. If I have 50 servers, I need to buy 50 public IP. That's why I'm not going with a static NAT into this design. No, that's why I'm not using static. I can go with destination NAT. I don't want to buy 20 public IP here. That's why I can go with DNAT concept, destination NAT. DNAT. How to configure DNAT? We'll discuss in practical implementation. We will discuss in lab. Let's talk about theoretical concept, story. Okay, what is DNAT? Yes, everyone. Yes, Ashwini.
Jitu, can you please give me a scenario? In what scenarios is the traffic initiated by the outside network?
See, if you talk about remote users, outside user, okay, for example, you want to upload your file, download your file in FTP server, for example, then you are a remote user, you are outside user. How to upload your file in your organization company FTP server? How to upload? You don't know anything about this private IP. You can only hit on public IP. Outside users, they can only hit on they don't know anything about private IP. They can only hit on public IP. So you can translate your public IP into private IP. Clear my point?
Okay, but say for example, if I'm going ahead and initiating an upload, and if my, for example, on the FTP, since we are going ahead and configuring it with the help of static NAT, the IP that gets assigned for FTP is say 154, but while my traffic is going out, instead of 154, if it reaches 150, how will the IP be able to recognize that this traffic needs to go to FTP instead of web?
Sorry. Wait. Can you repeat your question again?
Since with the help of static NAT, we will be going ahead and assigning IP, or say the IPs would be manually mapped that this is the destination IP and this is the source IP.
Can configure static NAT here, no problem. But for 4 servers, you need to buy 4 public IP. If you have 20 servers, then
20 IPs.
If you have 50 servers, then
50 IPs.
50 IP. You need to buy 50 public IP. What about cost? In DNAT, I need to buy only 1 public IP.
Okay, but my question is, how will we identify that this traffic needs to go to FTP instead of web? Again, like the same port concept?
DNAT? In DNAT or in static NAT?
In DNAT.
I'm telling you, give me some time.
Okay.
I'm telling you. So now we can implement here DNAT, destination NAT. Destination NAT, okay? Practical we'll discuss in lab, but right now we are talking about theoretical concept. We can implement DNAT here. So in DNAT, what we can do, I don't want to buy 20 to 25 public IP. No. So in DNAT, we need single public IP. In DNAT, in destination NAT, what we can do, we need to buy single public IP. 99.99.99.155, for example. We need single public IP. If you guys remember PAT concept, in PAT, we also required single public IP, right? In PAT, we can translate multiple private IP address with single public IP. And in DNAT, we need single public IP. Then what is the difference? Everyone clear this point? Remember PAT concept, PAT discussion. In PAT, we can translate multiple private IP address with single public IP. In DNAT, we need single public IP. Then what is the difference? So in PAT, we can translate. In PAT, we can translate multiple private IP address. We can translate multiple private IP address with single public IP. But in DNAT, we can map. In DNAT, we can map multiple servers. In DNAT, we can map multiple servers with single public IP. This one is a web server. Why? Because here we have port number 443. This 10.11 is DNS server. Why? Because here we have port number 53. This one is SMTP because we have port number 25. This one is FTP server because port number 21 is running. So in DNAT, we can map multiple servers with single public IP. How to configure DNAT? We'll discuss in lab. Let's talk about theoretical concept story. So now this time, if anyone from outside will hit on this public IP, If anyone from outside will hit on this public IP, and if this request is for port number 443, then as per your DNAT configuration, DNAT mapping, your firewall will redirect this traffic on 192.168.10.10 port number 443. If anyone from outside will hit on same public IP, because we have single public IP. If anyone from outside will hit on this public IP, and if this request is for port number 53, then as per your DNAT configuration, your firewall will redirect this traffic on DNS server. I can show you practically how to redirect our traffic. If anyone from outside will hit on same public IP, but if this request is for port number 25, or if this request is for port number 21. So as per your DNAT configuration, this traffic will redirect on SMTP. This traffic will redirect on FTP. Clear my point now? Clear this point, everyone?
Yep.
So in DNAT, we can map multiple servers with single public IP. But again, here we have a challenge. Into the scenario, we have challenge. Okay, in case, for example, in case if you have multiple, web servers in your network, multiple FTP server, for example, you have, this is web server 1, this is web server 2, for example, or in case if you have FTP server 1 and FTP server 2, FTP server 2, IP address 192.168.10.40, port number 21. So if I have multiple web servers or multiple FTP server, then because as per your DNAT configuration, this public IP, this public IP and this port number is already mapped with this 192.168.10.30 port number 21. It's already mapped in our configuration. It means outside user, what they can do, they can open their FTP application. They can put this public IP address information here in FTP software, in FTP application. Okay, they can put standard port number for FTP, port number 21. So outside user, they can open their FTP application. They can put this public IP information, port number 21. This is standard port number for FTP. So as per your DNAT configuration, if anyone from outside will hit on this public IP with port number 21, as per your mapping, your firewall will redirect this traffic on 10.30 port number 21, no problem. Now, what about FTP2? Because port number 21 is already mapped. It is already mapped with this FTP1. FTP1, port number 21 is a standard port number for FTP. It's already mapped with FTP1 server. Then what about FTP2? Clear this challenge? So here we have a concept of port forwarding. Here we can go with DNAT. We can go with DNAT with port forwarding concept. DNAT with port forwarding. What we can do in port forwarding? In port forwarding, we can use any unregistered port number. We can use any unregistered port number. For example, I'm using 8999. I'm trying to use 8999. So this public IP, my point is this public IP and this port number, I'm trying to map with this 192.168.10.14 port number 21. But this 8999 is not a standard port number for FTP. No. So into this design, what you can do, you can tell to your outside users. You can tell to your outside user, guys, whenever you will hit on to this public IP, please use for FTP service, please use port number 8999. Your outside user, they don't care. They don't care. They don't know anything. This traffic will redirect on FTP1 or this traffic will redirect on FTP2. They don't know anything. Your outside user, what they can do, they can just open their FTP application. They can put public IP information and port number they are using now. 8999. 8999. As per your configuration, your firewall will redirect this traffic on 192.168.10.14, 10.14 port number 21. This is called DNAT with port forwarding. Clear everyone? This point, this concept. Any question? Clear now? Aarti, Ashwini, Rajat, Ravneet, Rupa, Vivek.
Yeah.
Good.
Yes, Ashwini. Any question? Okay, good. Now let's talk about practical implementation, everyone. Practical implementation. Okay, we are trying to configure NAT here into this design. Okay, let's go to our design. So here we have, wait. Now, so here we have a NAT concept. Okay, wait, let me delete this rule. Rule number 2. I don't require this rule number 2. The single security policy we can utilize in our NAT implementation. Let's commit our changes. Because into this policy, what we have, any source trying to access any destination, action is allowed. Now let's talk about NAT implementation. So first, we are trying to configure source NAT. So you can click on NAT. Here we can create our rule for translation. So you can click on add. Here you can create your NAT policy rule. And I'm giving a name for this rule. For example, NAT-pol. NAT-pol1. So here you can define your original packet. You can define your translated packet. What is original packet? As per our task, we are trying to translate our private IP into public IP. This is our task. In source NAT, traffic will always initiate from inside network in source NAT. If traffic is initiated from outside, it's a DNAT. But in source NAT, traffic will always initiate from inside private network. So now into this task, we are trying to translate our private IP into public IP. So in original packet, what is our source zone? Source zone is a LAN zone. Traffic is coming from LAN zone. And what is destination zone? Trying to go on WAN zone. Okay, if traffic is coming from LAN zone in case and trying to go on WAN zone, okay, destination interface, for example, public facing interface. If destination interface is exit interface is Ethernet 1/2, trying to access any services, I'm using any services right now. Source IP, any, destination IP, any. If any source IP is trying to communicate with any destination IP. This is our original packet. This is what our original packet. Traffic is initiated from LAN side zone, trying to go on WAN side zone, any source IP, trying to access any destination IP. We can go with translated packet. We can go with translated packet. We can go with source address translation, or we can go with destination address translation. Right now, our focus is on source address translation, source NAT implementation. So here we can go with translation type. We can go with translation type. You can click on here. You can see these options are available. These options are available in Palo Alto Firewall. In Palo Alto Firewall, we have this option, dynamic IP and port. So in Palo Alto Firewall, you can say dynamic IP and port, or you can say PAT concept. You can say PAT, or in Palo Alto Firewall, you can say dynamic IP and port. Next option we have dynamic IP. In Palo Alto, you can say dynamic IP. Dynamic IP, it's a dynamic NAT. Dynamic NAT. Now, next one is what? Static IP. In Palo Alto, you can say static IP, but it's a static NAT, everyone. Static NAT implementation. So let's start our translation with dynamic IP import. Dynamic IP import, I want to translate with public facing interface IP. Actually, here we have two options, address type. If you select translation type, you can select your address type. You can select translated address, or you can go with interface. What is the difference? In interface address, for example, I'm using public facing interface. It means into this design, I'm trying to translate all LAN side machine with this outgoing interface IP. This is public facing interface IP. I want to translate all private IP address with this public interface IP, public facing interface IP. Or in case if you don't want to translate with public facing interface IP, you have a separate public IP. For example, you have 99.99.99.155 or 150. For example, you have a separate public IP. You don't want to translate with your public facing interface IP, your outgoing interface IP. You have a separate public IP. Then yes, you can go with translated address. You can go with translated address. Here you can add your public IP address information. Let's go with the interface option first. And our public facing interface is Ethernet 1/2. What IP address we are using? Yes, it's object name 99.99.99.1. You can just click on OK. This is our NAT rule. And into this NAT rule, you can verify here. See, let's commit first. Let's verify here. So this is our policy name, NAT-POL1. Okay. What is original packet? In original packet, traffic source zone is a LAN zone. Destination is a WAN zone. Destination interface is 1/2. Source address any. In translated packet, we are using dynamic IP import. In dynamic IP import, we are using this interface Ethernet 1/2. In Ethernet 1/2, we are using 99.99.99.1 IP. You can verify this translation entry through CLI command in case if you want to verify this translation entry, wait. So NAT show running NAT policy. So you can verify now here. You can verify now. Policy name is NAT-POL1. And NAT type is here we have from zone, LAN zone. Destination zone is what? WAN zone. Interface Ethernet 1/2. And For translation, we are using dynamic IP and port. Dynamic IP and port. And which interface? Ethernet 1/2. Now let's initiate our traffic. Here we have translation entry. So I'm trying to initiate my traffic from LAN side portion. So yes, traffic is traveling. Let's initiate more traffic here. Wait. I'm trying to access telnet, for example, 99, 99, 99.99.99.10. I think telnet is enabled. Let me check. Yes, telnet is enabled. Telnet is enabled. So username user1. Password 12345. Yes, I can access. Okay, as yes, traffic is traveling to outside. So traffic is traveling because of security policy, but this time our focus is on translation. Translation has happened or not. In real network, if traffic is traveling from private network to public network, you need to configure translation rule. So traffic is traveling. Let's verify here. Let's go to firewall device. You can click on monitor tab. You can click on session browser here. You can verify your translation entry. See, this first packet we can expand. You can verify security policy rule. It's hitting this rule 1 and NAT policy rule, NAT-pol1. What is flowchart? Client to server. Traffic is initiated from LAN side trying to go on WAN side. So you can see source IP is 200.100.100 IP trying to access destination IP 99.99.99.10. And this 200.200.200.100 is translated with this IP 99.99.99.1. Clear this point? Everyone clear?
Yes.
Everyone clear this point?
Yep.
Yes.
Yes.
Okay, now let's go to policy tab. Wait. Let's go to policy tab and I'm trying to go with, for example, I don't want to translate with outgoing interface IP. No, I have a separate public IP. For example, this one 99.99.99.150. I have a separate public IP. So you can go with translated packet. You can go with translated address. And yes, I can create public IP object here. You can click on address. You can give a name, for example, public -IP1 and public IP 99.99.99.99.150. So I have separate public IP. I don't want to translate with outgoing interface IP. You can click on OK. You can click on commit. You can click on commit. We can initiate some traffic. Please wait. Okay, now let's initiate our traffic. So I'm trying to ping 99.99.99.10. Traffic is traveling. We can initiate more traffic. 99.99.99.99.10. Let's initiate telnet traffic. Username user1. Password 12345. You can access traffic is traveling. You can go to monitor tab. You can click on session browser. Here you can verify your translation information. Translation happened or not. So let's expand this telnet traffic. See, it's telnet traffic, this session. So as per our configuration, this 200.200.100 IP is translated with this public IP 99.99.99.150. I hope it's clear. I hope it's clear. Can we take a break for 9 minutes?
Yeah, sure, Jitu.
Okay.
Sure, Jitu.
Let's continue at 7:20. Okay. We'll finish our NAT topic today. No problem.
Sure.
7:20. Please turn off your mic. Hi everyone, can you hear me? Aarti, Shuni, Ronit, Rupa, Vivek.
Yeah. I get it.
Okay, let's continue our topic now. Okay, so this is the option for dynamic IP and port. Okay, in dynamic IP and port, we can go with translated address or we can go with interface address. Next option we have dynamic IP. What is dynamic IP? Remember dynamic NAT? In dynamic NAT, we can create a range of public IP. We can create a range of public IP into this firewall device. So if anyone from outside trying to travel, anyone from inside trying to travel to outside, okay, they can get any IP address from this public range and traffic will travel. So here we can create a range object for dynamic IP. We can create a range object. Let's cancel this. We can go to object and I have, for example, public IP range. Wait. I have public IP range 99, 99.99.99.122, 99.99.99.125. So I have 6 public IP. So any 6 machine from LAN side, any 6 machine can utilize this public IP. Any 6 machine can utilize this public IP. So let's go to firewall device. We can create an object, address object. You can go to object option. You can click on address. Here we can create object. You can click on add. And I'm creating range objects. You can give a type, IP range. We can give a name. So public IP range 1. Now public IP is 99.99.99.122, 99.99.99.125. We can create a range of public IP here. Let's add this object into our policy configuration, NAT policy, translated packet, and I'm using dynamic IP concept. Yes, I can add object here. So object is public IP range. You can click on OK. You can commit your changes. And we can initiate some traffic from LAN side for verification. Please wait. Everyone, please wait, okay? It's taking time. Please wait. Okay, so we have 2 machines. Okay, let's try to configure IP address here. ncpa.cpl. IP address I'm using 200.200.200.40. 200.200.200.1 is a gateway IP. Now let's initiate our traffic. Let's initiate our traffic from both the machines. IP address address is IP config. So 200.200.200.40. I'm trying to ping 99 dot 99 dot 99.99.10 with -t. Traffic is traveling. We can initiate our traffic from here also. Let's try to access telnet traffic. Telnet traffic 99.99.99.10. Connection refuse. Wait. Let's initiate our traffic. 99.99.99.10. We are facing some issue. Check. Okay, let's initiate our traffic from this new machine. So telnet traffic 99.99.99.10. Port number 23. I can access, wait. .99.99.99.10. Yes, I can access. Username user1, password 12345. We can initiate our traffic from this PC number 2, 12345, and traffic is traveling through the power box. Okay, we can focus on translation method. Translation monitor session browser. We can verify our translation information. So telnet traffic. Let's say refresh this page. Wait. Okay, so we have two telnet sessions. This one and this one. Okay, wait. Yes, we have two sessions for telnet traffic. One session from 200, 200, 240. One session from 200, 200, 200.100. Okay, let's expand this. This 200, 200, 240, and this 200, 200, 200, this one. So now you can verify this 200, 200, 240 IP address is translated with this 99.99.99.124, and this 200, 200, 200, 100 IP is translated with this 99.99.99.122. Remember our range, everyone? 120 to 125. Clear this point? Clear this point, everyone? Okay, now let's talk about static NAT. Static NAT. So let's delete this entry. Wait. And I'm trying to create a static NAT, one-to-one mapping. What is static NAT? One-to-one mapping. So I have one public IP. Okay, for example, I have public IP 99.99.99.110, 100, for example. 99.99.99.100 IP. So I'm trying to map this public IP with this inside private IP address. Let's verify this inside private IP address. So I think we are using 200.100 IP. So let's create object first. We can go in Palo Alto Firewall device. We can create two objects, private IP address object and public IP address object. So you can click on add. We can give a name, for example, marketing-PC1. Just a name, okay, object name and IP address 200 or 200.100. Single IP address object I'm creating. So /value I'm using /32. /32 you can use for single IP address object. You can click on OK. Let's create one more object, public IP object. So static hyphen public hyphen IP1, just object. So public IP 99.99.99.100. You can click on OK. So we have two objects, private IP and public IP. These objects we can use in our configuration. Let's create a rule. You can click on add. We can give a name for this rule. So static hyphen NAT1. Original packet traffic source zone is a LAN zone. Destination zone is a WAN zone. Destination interface is public facing interface. To access any services, this time I'm not using source any. No, this time we are trying to configure static NAT, one-to-one mapping. So this time I'm not using source address any. This time I can add object here. Marketing PC1, I think. Yes, marketing PC1. I can add this object, marketing PC1. If marketing PC1 trying to access any destination, now we can translate. I'm trying to translate with static NAT. And yes, I have a public IP. Static public IP1. And here is a checkbox. Remember everyone, as I said, static NAT is what? Bidirectional, but it's not by default. Okay, you can select this checkbox here. If you are looking for bidirectional, so you can select checkbox. Let's select checkbox. We can verify that. Bidirectional, I want to use as a bidirectional now. You can click on OK. You can click on commit. Okay, let's initiate our traffic. So this inside machine, okay, 200.100. We can create one more rule, okay, no problem. Wait, this will take time. Let's create one more rule for REST traffic. So I'm creating NAT-POL original packet. If traffic is initiated from LAN side portion, trying to go on WAN side zone, destination address public facing interface, trying to access any destination, any services, any source address, trying to communicate with any destination address. For translation, I'm using dynamic IP and port. Okay. I want to translate with interface IP, and our public facing interface IP is 1/2, and IP address we are using 99.99.99.1. So as per our policy configuration, if this particular machine is trying to access any destination, we are using static NAT method. Okay, and we have a object static hyphen public 1, and we are using bidirectional method. But if any other machine, any other source IP trying to access any destination IP, for this we are using translation method, dynamic IP and port. Okay, and this public facing interface Ethernet 1/2 we are using for translation. So let's commit our changes, and we can verify this. It's like a firewall policy, security policy. Okay, for translation, it will always check from top to bottom. So let's initiate our traffic from both the machines. Okay, I'm trying to initiate my traffic from this 200.100. I'm trying to ping 99.99.99.10, and traffic is traveling. Let's initiate more traffic. Telnet traffic, for example, 99 dot, 99 dot, 99 dot, 99 dot 10. Traffic is traveling. Traffic is traveling. Wait, password. I think, wait. User 1, password 12345. Now let's initiate traffic from this machine. IP address we are using 200, 200, 240. Telnet traffic 99 dot, 99 dot, 99 dot 10. Username user1, password 12345. Let's verify our translation. So we can go to monitor tab, session browser. We can refresh this page. Wait. Okay, now let's verify our telnet traffic. So here we have telnet traffic for 200, 200, 240 IP address and telnet traffic for 200, 200, 200 dot 100 IP. Let's expand both. Now, as per our configuration, if 200, 200, 200 dot 100 is trying to travel outside, this IP is translated with this 99 dot 99 dot 99 dot 100 IP. And wait, if this 99 dot, sorry, 200, 200, 200 dot 40 IP is trying to travel outside, this IP is translated with this 99 dot 99 dot 99 dot 1. This is public facing interface IP. Clear? Aarti, Ashwini, Ravneet, Rupa, Vivek.
Yep.
Now, let's verify our bidirectional. Static net is what? It's a bidirectional, right? So if I'm trying to initiate my traffic from outside, if outside user, outside machine, okay, trying to access telnet traffic. Okay, wait. Let me enable telnet traffic, telnet service here. Wait. Telnet is non-enable. Okay, give me 2 minutes. Control panel. So we can enable telnet service for verification. Now username is user1. We can set password here. My computer, right click, manage. Local users, username user1. Password I'm using 123, 123. Okay, so from outside, I'm trying to hit on, wait. From outside, I can only hit on this public IP. Outside users, they don't know anything about private IP. They can only hit on public IP. So from outside, I'm trying to hit on this public IP 99.99.99.100. As per your static net configuration, this public IP is mapped with this 200, 200, 200 dot 100. So this traffic will redirect on this machine. On this machine, okay? On this machine, okay? Wait. Wait, it's taking time. Okay, traffic is not traveling from WAN to LAN. Why? Because we don't have any policy to allow our traffic from WAN to LAN. Can we continue our topic in next session, everyone? R3, Ashwini, Navneet, after this topic, after this verification.
Sure.
In next session, okay, let's verify. Let's create a policy here. DNAT we can discuss in next session. So I'm trying to create a rule. So WAN to LAN rule. So rule type is what? Inter-zone communication rule. If source zone is a WAN zone, because traffic is coming from WAN zone, any source address trying to go on LAN zone to access any destination address, any application, any service URL category, action is allowed. Okay, we can commit our changes. So we have rule this time. We have rule this time to allow our traffic from WAN to LAN. Yes, Rupa, any question? Okay. So now we can try. We can try from outside. Wait. I can try again for telnet traffic. Now I can try for telnet traffic. Okay, from outside, I can only hit on public IP 99.99.99.100. See, username, user1, password 123. This is inside machine telnet service. How you can believe? So let's create some folder here, CD, desktop, mkdir, hello class. So you can verify here on desktop. See, mkdir firewall 11. See, clear everyone? Source NAT implementation. Destination NAT will discuss in next class. Okay, please connect on same time. Bye everyone. Take care, guys. Bye everyone.
Bye.
Bye. Bye.